Hello everyone, I'm Dr. Anjan Das, Assistant Professor in Department of Chemistry, SRM Institute of Science and Technology, Kattankulattu, Chennai. So recently I have been awarded ARNF ECRG in 2025, and the theme of my project is an exciting and rapidly growing area in the modern chemistry, like asymmetric photocatalysis for the synthesis of enantiomer drug molecules. So, in pharmaceutical chemistry, the concept of chirality is extremely important. Many drug molecules exist as a two mirror image form called enantiomers. However, these enantiomers can have a drastically different biological effect. One may be therapeutic, while the other could be inactive or even harmful. Therefore, synthesizing an enantiomer compound is a key goal in the drug development. So to achieve a good enhancer selectivity, it requires chiral catalyst by asymmetric synthesis under thermal conditions. But over the past decade, photocatalysis using visible light to drive this chemical reaction has opened new possibilities. So asymmetric photocatalysis generally combines light activation with chiral inductions. Typically, a photocatalyst absorbs the visible light and resists to the excited state, generating reactive intermediates such as radical, okay, by electron transfer. At the same time, the chiral catalyst, often a chiral organocatalyst or a metal complex, control the stereochemistry of the reaction. So this dual catalytic system enables the formation of energetically pure products under the mild reaction conditions. So this approach offers several advantages, like it uses visible light, which is a clean and sustainable energy source. It allows access to the novel reaction pathways, which is not possible under traditional reaction methods. It often proceeds under mild conditions, improving the functional group tolerance. So importantly, asymmetric photocatalysis has been successfully applied in the synthesis of complex molecules, including chiral amines, alcohols, and many heterocycles, which are the key building block of many pharmaceutically important drug molecules. So in this project, I have proposed a new kind of heterogeneous photocatalyst, that is chiral covalent organic frameworks. So recently, chiral covalent organic frameworks has emerged as a promising class of material for asymmetric photocatalysis. It has structural precision, tunable functionality, and inherent chirality. So we can construct it from a well-defined chiral building block, and this crystalline material we can rationally design to incorporate a photoactive unit as well as a chiral element within a single ordered architecture. So once we excite this new chiral of material, the photoactive moieties generate reactive intermediates, and while the chiral environment within the framework framework channels govern the chirality in the photo reactions or the product. So there are several advantages of using this chiral covalent organic framework as the photocatalyst. So as it is a heterogeneous, so it is commonly insoluble in most of the organic solvents. So after the reaction, it is easily recoverable and reusable for multiple cycles. Highly tunable structure, we can tune the pore size, shape, and functionality, and we can control the reactions in the pore by changing the pore diameter of the chiral cuff. And then confinement effect. So reactants are oriented in a specific way inside the pores, which improves the stereo control or selectivity of the reactions. Okay, and it can efficiently harvest the light. So since it is a very conjugated system, so it can absorb the visible region light, which is good for sustainable chemistry. And sometimes the chiral curve acts as a synergistic dual functionality also. If we incorporate the photoactive moiety and the chiral group, they work synergistically inside the material and give better selectivity of the product. And definitely these material are very stable, thermally stable, so we can run the reaction in various temperature. Okay, and finally this is the green and sustainable approach, as we can recover and reuse the catalyst for multiple uh, cycles. So this is the main theme about my project, and thank you everyone.